Good morning, everyone. This is Jason Passini with IBM's Hybrid Cloud Sales team, and welcome to this week's Integration and Development webcast. Today is the final session of our five-part mini-series focused on Agile integration architecture, and we are pleased to have integration architect Kim Clark join us once again to lead this session. And just to bring you up to speed, if you haven't been able to participate in the preceding parts of this series, but we kick things off by talking about the need to break up the ESB and then transition into a discussion around decentralizing integration, the benefits of containerization, and then most recently, last week, we talked a bit about the role of API management within these Agile integration architectures. Today, we're going to conclude by talking about the role of messaging within this architectural approach. So like in the preceding weeks, I believe Kim's got about 20-25 minutes of content to share with you today, at the end of which we can take some live Q&A. And as always, if you do have any questions as we're going through the presentation, you can submit them to me via the chat. I'll try to keep an eye on that as Kim's speaking. And also for those of you that are looking to get access to the previous recordings in this series, just drop me a note with your email and I'll be sure to add you to our box site later today and you'll have access to all of that content. So with those handful of opening remarks out of the way, I'm going to hand things over to Kim and we can get started with this week's presentation.
Thanks very much, Jason, and a pleasure to be back, and well done anybody who stuck it through the whole 5 in the series. Yeah, great to have you back again. Just a quick reminder and a refresher of the core themes. We're talking about Agile integration architecture as the broad picture here. And it really comes down to these 3 themes around fine-grained deployment, decentralized ownership, and cloud-native infrastructure. And those themes have been running through as we've been talking about the different technologies as we've talked each week. And we've talked about how that affected the ESB. We've talked about how that's affected APIs. And this week, we're going to move on and take a look at messaging and see how things are affected there as well. And really, we'll see those same themes coming up to the surface, bubbling up to the surface, as ways that enable businesses to be more agile in the way they approach integration in exactly the same way as they are in the application space today. So let's delve into the messaging space specifically. And the first thing you'll probably notice from this diagram is this is the sort of overview diagram. We're going to drill into different aspects of it. But you'll see very much in evidence is this aspect of the fact that we're moving to the cloud, clearly, as we move across to the right, but to a multi-cloud kind of environment. And so we're looking to move to better ways to handle cloud-style, cloud-native environments, but also how we traverse across those. Messaging, of course, is all about transport. It's, you know, where in the previous weeks we've been talking about things like the enterprise service bus and its movement and API management, and those are things that are core components in the building of an integration, whereas messaging really is a transport layer. And so it's a slightly different theme this week when we look at it from that perspective. You'll also see some key text on the bottom there talking about some of the aspects around the decentralization, the self-provisioning, the platform managed and things that enable teams to be more agile and more effective on their own. So let's delve in and have a look at some of these concepts in some more detail. I think the first one is a change that's been happening for customers of, for example, IBM MQ, which is our core messaging capability. Something that's been happening in their environments for many years now. People have been moving away from having the message queuing capability sitting on a local machine alongside an application where they have to install it, manage it, and look after it, sitting alongside the application. The reason that we used to do that was to make sure that you could be sure you could always put the message onto a queue. You had that assurance that because you owned it, you looked after the local messaging capability, you could always get it onto that queue, and then it could traverse asynchronously out to the broader topology in its own time. Now, networks have got a lot more reliable over time, and so we've got more and more comfortable with the idea that something that lives across a network hop is always going to be there. And in addition to that, as we move into the world of containers, there's more desire to have an application component living on its own, just the process of the application, not having something else sitting alongside it. And so it would be desirable to use a remote connection rather than a local connection to any kind of message queuing resource. So with those two things together, as I say, gradually over time, people have been more and more using remote connections to messaging capabilities. And there's many advantages to that, not least in terms of the fact that you haven't got a local persistence to worry about as part of, for example, your high availability and your disaster recovery scenarios at the broader architectural level across your application. So you've got less moving parts to deal with at the local end, and they're more handled in the more the remote end. Now, that has a really big effect on how we can provide messaging. So instead of it being provided as something that you as an application owner have to install and worry about, it can instead be provided as a service and connected to remotely. And so, for example, IBM MQ is available as a service on cloud. And so you can have it as a managed service from IBM. If you do want to run it locally in your own environments, you can run it in a more service-like way. In fact, one of the most effective ways of doing that now, you can purchase MQ on an appliance. And it's quite surprising in the world of cloud to suddenly see something cropping up as an appliance, but it's been surprisingly popular. And the reason for that is because a lot of the subtleties underneath a messaging capability are about the persistence. How do I push things to disk effectively and still make them available in a highly available disaster recovery scenario? And some of that actually needs to have the right sort of concepts burnt right the way down to the operating system and the disks and everything. So rather than you having to make the choices around what type of disks, what type of fiber links do I put between here and so on, we can make those choices for you in an appliance. There's certainly no reason you have to go to an appliance. There's still the software, and there's still plenty of ways of making that feel like a service too. But it is worth noting that for these sort of things, the appliance has been popular. We're also looking at the fact that this is a multi-cloud scenario, so it's not just IBM's cloud. So you might want to, for example, make use of MQ in an Amazon environment, and so we provide a managed MQ in an Amazon AWS environments as well. So that's a big shift, really, to be able to say, I don't need to have a local messaging capability. I'm going to make use of one that's an as-a-service capability. I'm going to use remote messaging to that. There are some pros and cons into the subtle things that message queuing capabilities can and can't do when they're made remote. But generally speaking, we're finding people are able to do what they need in a remote scenario. And so that brings us on to this multi-cloud kind of discussion, because really what in the same way that HTTP is a ubiquitous mechanism for talking synchronously across different applications and indeed across different clouds, and it's something we pretty much take for granted. Messaging doesn't have a similar standard. It doesn't have a ubiquitous standard across the cloud, across the web. And so we need some kind of mechanism that will provide that for us. And this is not just about what's the wire format, what sort of thing we're sending. We could be using JSON payloads or XML payloads. It doesn't make any difference. It's really that substructure. It's how am I going to make sure that messages that I put into a queue in one cloud over here get reliably moved to another cloud over there. It's that sort of topology that underlies the whole thing, and being able to just connect the channels for messaging together across different platforms is a really powerful thing. It's kind of what MQ was originally invented to do all those years ago across different operating system platforms, but reinvented again across different cloud platforms. So that's become an important necessity across communication between these different cloud platforms. Many companies have got a multitude of different clouds that they're using. So moving on to another key aspect of how the way that messaging is being provided. Actually, this picture, you might notice that it doesn't mention messaging anywhere, although it is talking about messaging. Those flat darker blue boxes are the messaging capability. Actually, this change in style is something that's happening across many different aspects of componentry in the IT world, where they're moving into the more cloud-native style. On the left-hand side, we've got the traditional approach, which is to say, I'm going to have an active and a passive that are sharing a database underneath them. And they're sharing that data. This has been a challenge for databases, for queuing systems, and all sorts of things over the years. Anything that involves tight coupling with the persistence. And so the general idea is to provide high availability. I provide some kind of lock on that shared data, and if I release that lock, then the other side, one way or another, works out that that lock's been released and starts up or moves from warm to hot and starts processing the messages. And of course, the application then has to know how to find the active queue manager in this particular case. And so that's an active-passive style. It has limitations on how far it can scale, of course, because you've only really got one master available at any time. We've got some time taken in the failover, the detection of the fail, and the warm-up. And most importantly, we're dependent on this shared persistence, which is a challenging thing to achieve in a cloud-based scenario. And it's something we're often trying to avoid if we can. It's certainly possible to have shared storage in a cloud scenario, but it's something we're trying to avoid. So many systems are working across towards this alternative style where we have an active-active capability which can scale out horizontally, moving more and more copies of itself, each one being heterogeneous, each one looking the same. And so this could be orchestrated by something like, for example, Kubernetes or a container management, container orchestration system, where it can just simply replicate these things out. And the storage, you'll notice, is no longer shared. So we've got separate storage for each of the individual queuing capabilities, if you like. And optionally, we can also have that duplicating data across them. So we've got copies of the data on all of those local copies. And so effectively, we end up with this horizontally scalable active-active scenario. Failover, of course, is much faster. The load balancing across here is a much more straightforward load balancing of just passing the work across all of the sets. And we're not reliant on that shared persistence and any subtleties within the locking mechanisms of the shared persistence. It's just straightforward local persistence. And if we lose one of the cluster members, we can make use of the duplication to rebuild what we have. So things are moving from the left to the right as we move to more cloud-native scenarios, different flavors of the two sides, but we're certainly starting to see that shift across. And as I say, this isn't necessarily just focused on messaging. Anything that involves the componentry that works against persistence is moving into these sort of styles. So, oh, I apologize. I seem to have closed the application, or I think it's closed itself automatically. Just bear with me while I just bring that back up. Okay, coming back up. And I'll share again. Right, and we're back on track. Apologies for that brief technical error. So, so another thing that is almost, if you like, the reason why it's so valuable to talk about asynchronous communication when we're talking about modernization of integration is because there's been a resurge in interest in asynchronous communication. Now, over the last few weeks, over the last 4 weeks, I've probably barely mentioned it. I've talked mostly about synchronous communication, APIs being exposed, communication over HTTP, and so on. And for sure, a huge amount of communication with, for example, microservices within and across microservice applications is certainly going to still be done using APIs, using synchronous communication. But there is a downside to that. And you can see very clearly on the left-hand side, if a microservice is making synchronous calls to two other microservices, it is immediately dependent on them. It has a real-time dependency, and if either of those microservices fail, then so does the microservice A at the top. Now, really, one of the key tenets of microservices architecture is for them to be, each component to be completely independent of the others, not just in terms of the code being separate, separate libraries, separate release cycles, but also at runtime in terms of the real-time dependencies. If we really want to do that, then the only way to keep them independent at runtime is to have some asynchronous mechanism for communicating between them. Now, to just switch to a messaging transport but still do a request and a response doesn't really solve that problem, right? So that's just changing the transport to asynchronous, but you're still expecting a response from the downstream microservice. That hasn't really helped. What you really need to do is move to something more like an event-sourced model. What that means is that the data that, say, microservice B and microservice C in this diagram hold, instead of the only way of being able to get to that data being to call an API on the microservice, instead those microservices publish events out explaining the changes that are happening to the data that they own. So effectively, microservice A, instead of having to go and get the data in real time when the request comes in, it can subscribe to messages from microservice B and microservice C and build up its own local data store of all of the things that live in those other microservices. It's a copy, and there's a challenge with the fact that it's a copy, of course, that's data duplication, but it is a decoupled copy. So it therefore means that it can serve responses including data from microservice B and microservice C without having to go to them at runtime. So we've created complete independence. And this is the reason that asynchronous communications become so popular in the world of microservices and cloud-native applications, because it allows this complete decoupling. It is a much more challenging way of writing an application, potentially. We've got to think about the race conditions and the fact that we may have a different version of the data to another microservice does, and so on. We've got to consider how we get our initial understanding of what the data in microservice B looks like before we start subscribing to the changes. So there's all sorts of additional factors to take into account, but it does provide a mechanism for true decoupling of microservices. Now, I've been very keen here to weigh up the pros and the cons, and it's a very, this is just a small slide weighing up the pros and the cons very quickly, but to give you that understanding that there are two different mechanisms in play here. The event sourcing is a very popular pattern within the microservices community, but it's certainly not the only way you should be doing things. We're likely to see a mixture of APIs and events being used going forward. We're not expecting to see a complete shift across to events only. Now, we've talked about this idea of using events in a microcosm of within, if you like, one microservice application and a set of microservice components within there. But actually, it's also true at the enterprise level. We could look at a microservice application as being just one application within many within an organization. And it's, as a whole application, needing access to the data from the other applications or systems of record. And so it could, of course, make a request to APIs that we've exposed from those other systems of record, and that certainly will happen. There'll certainly be times when getting the information at real time is the right thing to do. But it could equally easily, just like the event source pattern inside the microservice application, it could listen to event streams coming from those bigger systems of record as well, things that are outside of the microservice application. And that's where we start to see an interplay between different styles of messaging and events. So it might well be that you've got MQ as a topology for communicating between the existing systems of record, and you want to listen in to the events that are passing around. You might have the right events available already running around on that MQ topology. And all you actually need to do is tap into those and start pushing those events up into the microservices area. Now, what I hadn't mentioned so far, of course, is that those event sourcing patterns that we're seeing in the microservices world are much more commonly being done with a different style of asynchronous communication. They're often being done using Kafka as an example, just one example, but a very, very common one. Apache Kafka is an open source project providing an event-based mechanism for passing messages around, as opposed to MQ, which is typical of the queue-based style. And so there's two different styles in play here. And what we're able to do is traverse across those two styles. For example, MQ can emit events onto a Kafka messaging hub, and so pass events up into the microservice application. And equally, they can be consumed in the other direction as well. So I've mentioned two different styles of messaging there, but I haven't really gone into the depth as to what the difference is between them. And that's probably the last thing I should put some focus on in the session today. So messaging, the one along the bottom, is traditional MQ queuing systems as they've been around for many years, very much focused on persistence of transient data that's moving into queues. We're trying to keep the queue depth as small as possible so that we're trying to keep the data flowing around the organization. And this is why it's good for passing things asynchronously across cloud boundaries and heterogeneous boundaries. It can be used for source to target, knowing where you want to send a message and getting it there, like a postal system, or also even for a request reply pattern as well. And it's reliable delivery. It's guaranteed once only, or assured once only delivery. Events, on the other hand, are working on a different premise altogether. They effectively allow you to build up a history of all the events that have occurred. So instead of it being a queue where the messages are destroyed, we keep a long audit trail, a big stream history of all of the events that have ever happened. And the advantage of that is that it means something like a microservice component, if it falls to the ground and loses its in-memory state, it doesn't have to have persisted that state. It doesn't necessarily have to have a persistent database where it's kept its records. It could say, well, I'm just going to go back to the stream history and read it again and build it up again. And that allows us to have a very different model for a microservice where it effectively almost treats the master as the event stream and then actually builds an in-memory copy when it needs one. We can also scale the consumption much higher with events because the way they're set up with the stream history, the server side, if you like, the big event history doesn't have to remember where the different consumers have got to. It's up to the consumers to know where they've got to in that event history. And that takes a huge load off the central event hub. It doesn't have to have a knowledge of the consumers, whether they've consumed something or not, perform transactions on their behalf, and so on. All of that pattern handling is left up to the consumers. Now, that does place a burden on the consumers to store where they've got to in terms of the offset and to manage much more of the transactional aspects of it, but it does provide for this very scalable consumption. And of course, the stream history is immutable data, so you don't go back and ever change any of that event history, so it can be used to provide that kind of audit trail. So two really very different types of messaging, asynchronous communication. I'd almost go so far as to say that the messaging queue style on the bottom is a communication transport, whereas the events is really another form of data store. It could, in some cases, with the event sourcing mechanism, be seen as a data store rather than as a communication mechanism. Very different styles. From IBM's perspective, we have a product which is now known as IBM Event Streams. It was briefly known as IBM Message Hub. IBM Event Streams is available in IBM Cloud. It's a Kafka implementation. We've set up and made all the decisions around how to set up Kafka in a highly available way across regions and so on. You can also run it on-premise in IBM Cloud Private as well. So if you want your own separate instance, you can do that. And then, of course, we have MQ to provide the messaging capability, the bottom half of this diagram. And we have the ability to configure connectivity between those two in a very straightforward way so that you can emit and receive events between the two sides. So that gives you a little bit of an idea as to how the asynchronous communication space is changing. It's just another aspect of our broader platform. So we see this as one platform for all the different aspects of integration, and we've discussed pretty much every piece of that over the last few weeks, from the application integration, the breaking up of the enterprise service bus, to the APIs and the messaging and so on. And so with that, we've actually come to a completion point on our overall series. We've talked about all the different aspects, and we've gone into some depth about the conceptual aspects of Agile integration architecture and decentralization and being more cloud native and so on. So with that, I'm happy to open up to questions from anyone on this last in the series.
Great, thank you, Kim. Yeah, there are a handful of questions in the chat. One is regarding active-active. The question is whether Red Hat OpenShift Kubernetes is the only way to achieve high availability.
Well, one of the nice things about using a Kubernetes capability and orchestration framework is that it will provide the load balancing on your behalf. But there's nothing particularly special about that. That's something that you could have created yourself as well. So, we've been creating highly available load balanced infrastructures for many years. The advantage of a container orchestration system is that it does it on your behalf. So I think, unless I'm misreading the question, I think the advantage really is how much is provided by the platform for you, rather than you having to set up load balancing and everything else yourself.
We also have a question here. Someone's asking whether you can compare, pub sub, whether it's MQ or WS notification versus Kafka.
Yes, that's an interesting one, and it doesn't actually say on that preceding chart anything about publish subscribe, because it's a slight overlap area of the two different styles. Indeed, you can do publish subscribe in a messaging environment. And it tends to be done in a more durable subscription. So you set up queues for the individual subscribers, and then people, actually destructively take messages out of those queues. Whereas in the event style, we're holding this event history, and the consumers can come in as and when they like and pick up their particular subscriptions. One of the things you find that's different between the two, so effectively what I'm saying is publish subscribe as a pattern is available in both of these categories. What you tend to find is that in the events place, especially in Kafka, the concept of a topic is a very heavyweight thing. It's actually, if you create a new topic, you're actually burning something into the way you're setting up and partitioning the data on disk. So it's quite a major thing to create a new topic. Whereas in the messaging environment, that tends to be part of the metadata that's passed around with a message, and you can have hierarchical topics that can be quite dynamic. So the way that publish subscribe is done in the two different cases varies, and depending on your use case, you may choose one over the other.
So, folks, if you do have any additional questions, you can continue to submit them in the chat, or if you wish to take yourself off mute, you could always pose the questions to Kim directly. And just one thing, given some of these questions about Kafka, and I know some of Kim's closing comments as he was wrapping up the presentation, we are going to be having a demonstration of IBM event streams, not next Friday, but the Friday after Thanksgiving week. So if you did want to, see some of the tool in action, that would be a great opportunity to do so. And that is IBM's Apache Kafka offering for the enterprise. So highly recommend you check that out as well.
Perfect timing.
So I did just get another question here asking for your thoughts on Kafka versus MQ and their relationship to orchestration versus choreography of services or processes.
Oh, that's a good one. Yes, absolutely. So in a sense, this idea of if we just sort of take those two terms first of all and make sure we're clear on it. So if we're talking about orchestration versus choreography, orchestration is where there's some master controller that's that knows where it's got to in a sequence of requests that are being performed. Whereas a choreography is where each of the individual tasks being performed knows how to do its task, and then it completes and it tells the next person in line, and the next person in line does their task and then passes it on to the next one. Now, there are two different ways of getting multiple tasks done. One of them has a first-class notion, if you like, of the process. It knows where it is, it knows the state, and the other one distributes that knowledge of the process down into the chain of commands that are happening underneath. Now, effectively, the way I've described it just there, you could do those either with events or with messaging. And I think it comes down to what kind of dynamics you need within that process and how you're going to be able to make adjustments. But there isn't really, necessarily one better than the other when it comes to handling choreography or orchestration. Indeed, to do orchestration, you need a third party that's controlling the overall set of requests that are occurring. And so that might have to be something like a business process management layer or something like that actually is performing it. Now, there's a possibility that the question came in relation to performing a number of different transactional requests, which is something that really only the lower half, the messaging technologies, have the capacity to do. If you wanted to do something in the sense of controlling a transaction, a two-phase commit transaction across a number of different systems, then generally speaking, it's only the messaging capabilities that have that ability. And so that would be an example of orchestration, if you like, whereas if you're in the events world, you'd have to do it in the style of more of a choreography style, because it doesn't have that kind of two-phase transactional commit capability.
So, folks, if there are any other questions, feel free to ask them now. Otherwise, I would ask that you please take a look at the poll that should be opening up on your screen now. If you could just give us some feedback on the session, that would be great. And throughout the duration of this mini feedback has been consistently very positive. So thank you very much for leading this series of webcasts.
Yeah, certainly been my pleasure, and delighted to have people coming back, and great to hear that feedback. Thank you.
Okay, so if there are no other questions, I think we're safe to conclude. Hope everyone again found this to be an informative series. Sounds like it's been a very valuable use of everyone's time. So hope you can rejoin us again in 2 weeks, and hope you have a great day and enjoy the Thanksgiving break next week. Take care, everyone.
Cheers. Thanks, everybody.